So today I want to talk about something that's been causing a bit of confusion in RHOSO 18, and that is the bare metal provisioning process and how we leverage the MetalCube project to provision the nodes for the data plane. So obviously we have OpenStack Ironic, which is a project that provisions bare metal servers to be used as compute instances in OpenStack. And in OpenShift, they have a project called MetalCube. It also leverages Ironic, but they use it to provision bare metal nodes in the cluster. So the OpenShift masters and workers, for example, in a bare metal deployment using IPI will be deployed with the MetalCube project. So one thing that we really wanted to try and do was not reinvent concepts that OpenShift already had. So we didn't want to introduce our own bare metal provisioning infrastructure when we could leverage something that already exists in OpenShift. And we've done that pretty much with everything. We didn't want to reinvent the wheel for configuring networks, because we have the NM state operator, for managing TLS certificates when we have Cert Manager. So all of the OpenShift side setup things are documented in a way that points back to OpenShift documentation until you get to a point where you're installing the OpenStack operator. So when we create the data plane, the first thing we need to do is obviously provision some servers somewhere that we can then deploy to. So we switch over to my screen share here. So we have a look at the OC get BMH, which is BareMetalHosts in all namespaces. We can see that this cluster has 3 masters, so OC get nodes. That's these ones. So they're provisioned by MetalCubed. And then I've registered this one here in the OpenStack namespace. So if we take a look at what I did to register that. So I'm creating a secret here, the username, admin, password. So that is the information that MetalCube needs to communicate with Redfish and log in and do the power management and everything of that node. These are all virtual machines for me, but obviously it's the same process if you have bare metal nodes. And then I have a bunch of information about the bare metal host itself. So I'm going to create it in the OpenStack namespace. I've just given it a name here, and I'm labeling it. Pretty importantly, I'm labeling it here with the label for app OpenStack. And then under the spec, I'm just providing the information about the node. So this is the Redfish URL for this specific node, the MAC of the interface that I want to boot mode UEFI, and I'm setting the root device hint. So in this case, it's VDA because I'm using the VirtIO driver to add in a virtual disk. And we can see that that node is actually this one here. So I've got 2, so I can do some scaling, but we're going to look at specifically this node here. So as I showed, this is the node that's been created. And we can see all the information about it here. So now we need to create a consumer for that. And the way we've tried to handle this is to put it all into the node set so that you provide the information to the node set, and we'll take the relevant pieces out of the information you give us in the node set, and we will go and then provision that node. So we take a look at my node set. So we can see here, this is the bare metal information that I'm providing, right? So here's that label selector. So we're saying we want to select bare metal hosts with the label app OpenStack, because I don't want to provision nodes that are supposed to be used for OpenShift. I want to provision nodes that are for OpenStack. The control plane interface, so it has an interface on there and it uses Cloud Init to go and configure network information. The user is going to be Cloud Admin because I'm using the RHEL Cloud image. And the namespace is the OpenStack namespace. So what happens then is it takes the list of nodes that you have under nodes. So if I had, for example, another node down here, we'll call it 1. Right, so EDPM compute 1, then it's going to go and look for 2 bare metal nodes with the label selector app OpenStack in the OpenStack namespace. But in this case, we just want to provision 1. So I'm going to remove that. And then I've got an SSH key here that will be inserted. So that is a secret in this namespace and it will be inserted into the node as we provision it. So then what we can do is we can just create that. And we can see what happens now is we're waiting on NodeSet bare metal provision to be ready. So if we take a look at the pods in this namespace now, we grep for provision, we can see that 11 seconds ago, it started this provisioner pod. So that contains, it's just a web server. It contains the information that the node needs to boot. So if we see logs on that one, you can see here that we're getting Apache information back. And as the node boots, it's going to reach out to this web server and get all the information it needs to pull down the image. So it can take a couple of minutes, so it hasn't booted yet. If you want to follow along with the logs, then we have the metal cubed bare metal operator logs is one place to follow. So if there is any errors, for example, maybe something wasn't created in the right namespace, or it can't find any bare metal host to provision, you'll see that here. But you can see in my case, it is trying to provision it. We can see here, for example, it's talking about the EDPM hardened image. It's checking the image settings. So it's obviously found the information and it's waiting now for the host to become available. So if we go OC get BMH, we can see that that node has now moved into the provisioning state. And if we do a logs on that provision server, we can see that it reached out here to pick up that EDPM hardened image. And then if we virtualist, we can see that it's now up and running. So now it's just a matter of waiting like you normally would with a triple O deployment when you're waiting for your nodes to be provisioned. So that node will, when it's finished, move into provisioned. And at that point, we can start the deployment. So when you create a node set, all it's doing is this basic setup. It's not going to actually deploy OpenStack on that node. We just provision the bare metal node and then we wait. And then you need to create an OpenStack data plane deployment, and that will actually kick off all the jobs. So we'll wait for this to be provisioned and then we'll kick that off. So you can basically consider the metal cubed project to be analogous to the undercloud ironic instance that we were running in triple O. So we obviously had ironic on the undercloud, and then we would deploy ironic on the overcloud if you wanted to use bare metal provisioning for your instances. So in this case, the metal cube project takes the place of our undercloud ironic instance, and it's used to provision the nodes that we'll use for our data plane. The other logs you could check if you wanted to follow along with what else is happening at the time. So there's a container called Metal3 ironic. So you can see here I'm doing OC logs in the OpenShift machine API namespace. And there's a deployment called Metal Cube. So we're going to follow the logs of the deployment Metal Cubed and the container Metal Cubed ironic. So follow along with those logs. Again, this will show up any errors with trying to power on or off the node, trying to set it to Pixie boot, whatever might happen from the ironic side. This is where the logs are going to be. So you can see there, I'm just getting status 200s from everything we're trying to do though. So everything's working fine. And the other one there is the RAM disk logs. So there's a Metal Cubed RAM disk logs container. So when the node is provisioned, the logs from that process will be dumped in here, and you can go through, see if there's any errors. Like for example, if it couldn't find the disk that you provided hints for, like dev VDA in my case, those logs will be in here. It'll say, hey, there was no disk, I couldn't write anything to. So if you have a UPI deployed environment where you haven't used Metal Cube to provision your OpenShift nodes, what you'll find is that you don't have any of the Metal Cube pods deployed. So we check this environment. So this is just my single node environment that I have running on top of the rack behind me. So I don't have any Metal Cube pods. So if I create a node set here, it's not going to be able to provision anything. So what we've done is we've documented, and I'll just pull up that docs link so we can talk about it. So what we've done here is we've documented how to get those Metal Cube pods up and running, and that is by creating the provisioning custom resource in the cluster. So down here we see a provisioning CR is available. So I'll scroll up a bit actually. So you can see here a provisioning CR is available in RHOCP. So there's a link here that we can click and we can go to how to configure the provisioning CR in the cluster. So we can just take this example here. So we can see what we're going to do there is we're going to create the provisioning resource, and we're going to create it with, in our case, we're going to watch all namespaces. So this will allow you to create BareMetalHost instances in the OpenStack namespace, for example, and the provisioning network needs to be disabled in our case. So we'll just create that. And then what we'll see happen is that it will start to create those metal cube pods. So this provisioning resource is what kicks off that process. So the difference will be when you do an IPI deployment using Metal Cubed, it has a provisioning network. So there's an interface on the master nodes that handles all the pixie booting and provisioning of those nodes. When you do it in a UPI environment, you don't have that provisioning network. So we need to set provisioning network to disabled, and we're going to use the primary interface on the OpenShift nodes to do all the pixie booting and management of those nodes. So that's the prerequisite for the UPI environments that don't have the Metal Cubed instances already deployed. So we'll go back to our node now. We'll just check on this BMH. So we can see it's provisioned there now. So we do OC get OS DP NS. We can see deployment isn't started. So the next thing we need to do is just create that deployment. So we'll do OC, we'll have a look at the file first. Yeah. So this is the deployment. Nothing to it really. We're just going to specify the node sets in the OpenStack EDPM iPhone namespace. And what we will see here is that the deployment is now in progress. And we can see that deployment's in progress. So if we get jobs now, we can see that this repo setup job is running. So this is a custom service that I've created to just install some CentOS repos. So we do OC get OSDPS because it's for service, YAML, and it's called repo setup. We can see there that I've just provided a bash script basically just to install some repos on that node for me. So we just follow along with the logs of that job. You see that I've got Ansible debug enabled. That's because I provided the environment variable in my OpenStackDataPlaneNodeSet to get all the debug information. So we'll just wait for this job to finish, and then we'll see that the next one launches, and we'll probably wrap it up there. The main point of this is just to demonstrate the metal cubed aspect, because it does cause some confusion. We're not using our own OpenStack Ironic deployment. We're using the Ironic provided by Metal Cubed so that we don't have to reinvent the wheel or add additional complexity to the deployment. We can just use something that pre-exists already in OpenShift. So from the perspective of what actually happens to do that, so obviously we create the node set, but then we also have a CR called OpenStackBaremetalSet. So you can see here, for example, this goes and adds some additional information. So it takes the basic stuff that you've provided on the node set, and then it goes and adds some additional information. So for example, we can see there the containers it'll use for Apache and the provisioning agent, and you can see the image URL we're going to use to actually deploy to the node. So that's the EDPM hardened UEFI one. And then it just reports the status of what's happened. So it gives you the IP address. It's got the network data secret name and the user data secret name. So that's obviously used for Cloud Init to provision the networking, and then information about the user. So adding in the SSH key and those things, for example, and the deployment secret SSH key, which is the one we provided on the node set. So we can see now on that repo setup job, we have 1 of 1 completion. So that one is finished. And now we can see the next job has launched as well. So we can do OC logs, F, job. So this is the download cache job. So we can see that the DataplaneNodeSet is just going to sit here and work through the listed services on the node set. So we've got repo setup, download cache, going to sit there and work through each of those services now to get them deployed on our EDPM compute node. So we go OC get OSDPD. We can see the deployment's in progress. And if we have a look at the jobs that have been created, we can see we've got one here that's running, which is Nova EDPM Compute. So we can just follow along with the logs of each of those services there now until our node has been deployed. So we're also able to log into the node. So you can see here, for example, so SSH to Cloud Admin, this is the node running, and we've got some containers that are all starting up here now. So this will now start the Nova ones, libvirt, and then we should be pretty much ready at that point to start deploying nodes, start deploying VMs. So just as a quick summary, the first thing that you need to do is identify whether you're using an IPI deployment, a bare metal IPI deployment, where the installer provisioned the metal cubed infrastructure for you and then use metal cube to provision your masters and workers. Or if you're using UPI, you need to create that provisioning resource. So that's the one we created over here. So you can see there that this is the provisioning resource we created, and we just created it with watch all namespaces so that I can create BareMetalHost instances in different namespaces. So you can see I've got the one for OpenShift in the OpenShift machine API namespace, and I've got the one for OpenStack in the OpenStack namespace. In the UPI environment, I won't have that extra NIC, so we need to set the provisioning network to disabled. Whereas in the metal cube deployed environment, if I go OC get provisioning -o YAML, we can see that I have a provisioning interface. It's on EMP1S0, and these are the provisioning MAC addresses of my master nodes in that environment, and the provisioning network is managed. So this is the difference between an IPI and a UPI environment. So you just need to identify which one you've got. If you've done IPI, then you already have this. You don't need to take any extra steps. If you've done UPI, you need to create the provisioning so that it'll deploy metal cubed for you. So after that, you need to register a BareMetalHost. So that's this type of information here. So the first thing is the secret. So this is going to be the information that it needs to log on to your node. So a username and a password, in my case, just admin and password. Then we need to register a BareMetalHost. So that's this one here. So you can see I'm just giving it a name. I'm telling it I want to deploy it in the OpenStack namespace. I'm giving it some labels, and those labels are what we will use from the node set to select the BareMetalHosts that we can use, because you might have 100 registered, maybe 50 of them are for OpenShift and 20 are for OpenStack, or whatever way you want to have it. Just make sure you label the ones you want to use for OpenStack so that we have a way of identifying the nodes that you wish to use. Then we can see that I have an address, which is my Redfish address, and the credentials are the ones we created up above, right? So the node BMC secret, and then you can see this one here is the node BMC secret. So that's the information it needs to log onto the Redfish URL. I'm telling it the MAC address of the interface that I want to configure. I have two interfaces on that node. One will be used for provisioning, and the other one will be used for the networks. Boot modes, UEFI, and then I'm just giving it some root device hints. So obviously it's probably not recommended to use dev-VDA because that device could change each reboot. So just use the actual path, but there's examples of that in our documentation. So once you've created that BMH, it will introspect it for you. And then the next thing you need to do is create that node set. So here's the node set I created. So you can see when we were looking at the Ansible jobs, you can see there was a lot of velocity, and that's because I have Ansible velocity set to 4. We provided a list of services. So we looked at my repo setup service, which is a custom service. The rest are all standard. And then this is the bare metal information under BareMetalSet template. So you can see there I'm giving a BMH label selector of app OpenStack. That's the label we spoke about. The control plane interface, that's the interface I want to use on that node to have my control plane SSH for all of the job pods that will run. So that's on EMP8S0 in my case. I'm going to use the cloud admin user because we're using a cloud image that has the cloud admin user. And the namespace I deploy that BMH in is the OpenStack namespace. Now, as I said, that's all you need to do. If you're deploying 50 nodes or 10 or 1, you don't need to add anything additional here. Get rid of that. You just need to add the nodes you want to deploy under here. So you could take this and paste it a couple of times down here, and then go through and change them to EDPM 1, 2, 3, however many nodes you want to deploy. So the number of nodes you have defined under the nodes dictionary will determine how many nodes we provision using that app selector. And then the SSH key is the one we will use Cloud Init to put on the node so that you can SSH in. That's why I'm able to SSH in. And that's basically all there is to the bare metal provisioning side of things. So I just wanted to make this video to really highlight that we use the Metal Cube service. We take information that you provide to us from the node set, and we use that to render a OpenStackBaremetalSet CR. So we can see that here. Right, so we've taken that information, there's the label selector. It's gone and assigned an IP address for us. And then the OS container image URL, this is the actual like overcloud full image that we're going to write to the nodes to start provisioning. So once you create that node set, as I said, it's just going to stop. It's just going to provision that bare metal node, and then it will wait. And the next thing you need to do is then create an OpenStackDataPlaneDeployment, which is OSCPD, which is what we did. We can see, for example, once I created that, it started to launch job pods, and those job pods are going out and configuring everything on that node. And we can see when we log into the node, if we do that, it's starting to configure those containers for us there. So that's all I've got today, just a little overview of the bare metal provisioning process that we're using, leveraging MetalCubed and provisioning those data plane nodes. I hope that clears up the confusion of how we use MetalCubed versus what the OpenStack Ironic service is doing that we're deploying as part of the control plane that will be used to provision bare metal instances in your cloud. But for actually provisioning the nodes that we use, the MetalCube service is analogous to Ironic running on the undercloud in AAA. So I do hope that clarifies any confusion that might have existed there. I know there's a lot of moving pieces, but I hope you're finding it a bit easier to manage in this new format, a little less confusing. If you do have any questions, if there is still any confusion, feel free to let me know in the comments below. I'm pretty active answering questions, and I'm always happy to help people understand and make things a little bit more seamless for you. So thank you very much for watching the video. Let me know if you have any questions, and I'll see you in the next one.